Okay, let's look at winter 2019 problem number 4. So the situation is we have a boat that's going from point A to point B. It's directly north of it, 20 miles north of it when it starts out is a lighthouse. And this angle is 52 degrees. It makes an angle of 52 degrees to go over here. And we want to figure out how fast the boat's going. So basically we know it takes 3 hours. Okay, it takes 3 hours to go from A to B. So we need the hypotenuse, which is the distance. And we know the angle, and we know the adjacent. Remember, the adjacent is always the side next to the angle that's not the hypotenuse. So for part A then, we want to figure out the speed that it's going. So we need to figure out the hypotenuse, and we just divide by 3 hours. So we have the angle, and we have the adjacent and the hypotenuse, and we go through our trigonometry and think, okay, let's see. Cosine, some old horse, the sine is opposite of hypotenuse. Cosine is adjacent of hypotenuse, and that means it's got an adjacent hypotenuse. That's what we want. So we write down cosine of 52 degrees is equal to the adjacent, which is 20 miles. I'll just write that out. The adjacent divided by the hypotenuse, which is the adjacent is 20 miles. We'll just know we're getting our answer in miles, divided by the hypotenuse, which is what we want. And then we plug in cosine of 52 degrees into our calculator, and this time make sure your calculator is in degree mode, because it is a degree thing. So cosine, and I get 0.61566, goes on forever. So therefore, the hypotenuse is, just switch those two. So the hypotenuse is 20 divided by that, 0.61566, which is times 20. I get 32.485, good enough, miles. That's how far the ship goes. So its velocity, or speed, I'm going to write v because S looks like seconds. Its velocity is the distance it goes divided by time. It goes 32.485 miles divided by 3 hours. So divide that by 3. And I get 10.828, and like them, I'll just round off to 10.83 miles per hour. Miles, we can just write mph, miles per hour. Okay, so that's how fast it's going. Then, part B, they say, what's the closest distance between the ship and the lighthouse? What's the closest it gets? So let's redraw that picture here. And for the closest distance, so here's B and A, and here's the lighthouse. Then this is a right angle, right? For this line from the lighthouse to where it is, we know that's got to be a right angle. So then we want to figure out that distance there. So I call that distance D. Okay, so then we still know this is 52 degrees. We know this is 20 miles. And then we can figure out this side. So now, let's see, this 20 miles is hypotenuse, right? So this is the adjacent, and what we want is opposite the angle. So we know that sine of the angle, sine of 52 degrees, sine is opposite over hypotenuse, so, S-O-H, or some old horse, what I remember, sine is opposite over hypotenuse, which is, so I'll write that down. So this is just all right angle trig problems. So that's D over 20. And we plug in our calculator, sine of 52 degrees, 52 sine, I get 0.788. And so distance is 20 times 0.788, and that is, I get about 15.76, so 15.76 miles. Okay, so that's that one. Just remembering the closest it gets, the smallest that leg is, the height of that triangle is when it's perpendicular. Alright, that's part B. So let's look at part C now. And what do they want? Part C. Part C says, what distance between the ship and the lighthouse? Oh, sorry. Write the distance between the ship and the lighthouse as a function of time, where time is the number of hours past midnight. Okay, so the ship starts at midnight, which is nice. So, so that's t equals 0. So it starts at t equals 0, and then goes in t equals 3 hours. It's there, and we want to know how far away it is from the lighthouse. Now we know how far away it is in the beginning. It's 20. We can figure out how far away it is at the end, this distance here. We could figure that out, but we want to know where it is all the time. So basically, we redraw the picture. I don't know if I can fit it on the bottom of this page. And we choose some random place where the boat is. There we go. Choose some random place where the boat is. And we make this here our 0, our axis. So we maybe go like this here. Make that our axis here. And so this thing has position x as a function of time and position y. Our boat has position y as a function of time. So this point here is, it's 20 miles north, so it's x value is 0, because we'll produce our axis here, right? So our x value is 0. So at that point is 0, 20. And this point we can write as x, y, and they're both functions of time, right? It's changing as it goes. But I'm not going to put the parentheses there right now because that just muddles it up. So the distance formula, distance between any 2 points, is it's just a distance between any 2 points is just the x difference between them and the y distance between them. So here, the distance between the 2 points is the difference in x's, which is x minus 0 squared. It's just the Pythagorean theorem. Distance squared is a square root, or distance squared is x squared plus y squared, or take the square root. And then plus the distance in the y position, so y minus 20 squared. So we just got to figure out what x and y are as a function of time. So we need to know its x velocity and its y velocity, and then x, the x value, is vx times time, and the y value is vy times time. So how fast is it going in the x direction, and how fast is it going in the y direction? Okay, and the easy way to figure that out, we know it takes 3 hours to get to here. Okay, 3 hours to get there. And in that 3 hours, in the x direction, it goes this far. It goes this distance here, the top distance, and we don't know what that is. It's the one thing we don't know, so we're going to have to figure that out. That's the opposite, right? The x distance was the opposite up here. So let's call that the opposite. And we still know that this angle here is 52 degrees. My picture's getting kind of messy. 52 degrees. So let's do the x one first. So Vx, we got to figure out what the opposite is, because that's the distance it goes in the x direction. So the opposite, let's see, that's sine is opposite over hypotenuse. Or we know this is 20, so we could use tangent. Tangent is opposite over adjacent. We know this is 20. Now we know the hypotenuse we figured out was what? 32.485 miles, but 20 is so much cleaner, so let's use tangent. So tangent of 52 degrees is opposite what we want, the x distance, divided by the adjacent, which is 20, and tangent of 52 degrees, again, make sure you're in degrees, still is 1.2799, pretty close to 1.28. So our x distance, or the opposite then, which is equal to the x distance it goes, is 20 times 1.28, which is about 25.59, pretty close to 25.6. So 25.6 miles. It does that in 3 hours. So Vx is 25.6 divided by 3. Divide that by 3, I get 8.53, close enough. 8.53 miles per hour. And I'm just going to know, we know that in miles per hour. Time will be in hours. This is in miles per hour. I'll write it out, but that's our Vx. Now we need to find Vy, and then we know x and y. So, and I'm out of paper, but I have more. So let's see, Vy then. Okay, I'm on the camera barely. Vy is the easy one. Vy is the y distance it goes, but we know the y distance it goes is 20. It goes 20 north, 20 in 3 hours. So that don't have to do any fancy trigonometry. 20 divided by 3, and that's 6.666 forever. Let's say 6.67 miles per hour. Okay, now we know the x position. X is Vxt, which is 8.53 t, just knowing that t is in hours and this is in miles per hour. And y is Vyt, which is 6.67 t. And finally, then we can plug into our distance formula. So the distance between them is the square root of difference in the x values. The x value here is 0 of our point, so it's just x squared. So it's 8.53 t squared plus the difference in the y values, which is 6.67 t minus 20 squared. And there. So that is the distance at any time we want. We can plug in t here between 0 and 3 hours, and we should get how far away they are. So if we plug in 0 for t, we should get that it's 20, because it starts off 20 miles south. We plug in 0 for t, this is 0, this is 0. It's just the square root of 20 squared, which gives us 20. It's always nice to check your answers like that to make sure it makes sense. And when we plug in 3 hours, we should get what the opposite was, which we figured out that was 25.6 miles. So if we plug in t equals 3, we should get 25.6 out of this. That's a little bit harder to check, but the t equals 0 one's easy to check. It's always good to check that and make sure it makes sense. Okay, hope that helps.